Forward. All right, so the first thing that we're going to talk about is R value, and this is actually the correlation, which is the strength of the line. Okay, and that's just how good is it? Does it fit the data well or not? Okay, so the closer that it is to 1, it can be positive or negative 1, the better it is. Okay, so positive 1 is a perfect positive correlation. That means that the graph looks like this and the points are straight on the line. So we're doing a line of best fit. Oh, y'all, I did it this morning too. It's every time.
I thought maybe it was warming up.
No, I did it. Sorry, y'all. Yell at me next time. It's okay. It's been a day. I'm like everywhere. Tell me if there's anything else I do wrong. I don't feel bad for you correcting me, as long as you're nice to me. All right, so sorry. R value is correlation. It's the strength of a line. So if you have a scatter plot and you have a line that pretty much goes through all of your points, that's a perfect line. Okay, so its R value is going to be 1. A high positive is going to be like the points are real close to the line, but maybe they don't all touch it. Okay. A low positive is going to be that you can tell that it's a positive correlation, but maybe not many of the points touch it. Okay. And we're going to see all of this on our calculator. 0 correlation means that these plots are scattered everywhere. There's no positive or negative. You can't tell. Okay. You can't tell if it's increasing or decreasing. It's going to work the same way for the other ones, except for we're going to talk about decreasing. So you'll be able to tell that it's decreasing, but again, maybe not all the points are on the line. A high negative means that we really can see that it's decreasing and they're really close to the line. And I'll give you a minute to copy all this. And then perfect is that every point is on the line. So I'm gonna write this in a minute because I know that you're still copying or whatever. But there are 2 things that the correlation tells you. The first one is it positive or negative? Is it going to be a positive line or a negative line? And then it tells you how strong it is. Is it a really good line or is it kind of blah line? Okay. So 2 things it tells you. The first one, is it positive or negative? How will you know? If it's a positive number, then it's positive. If it's a negative number, then it's negative. If it's close to 1, it's strong. If it's weak, it's close to 0. So the 2 things that it tells you is if it's positive or negative. And again, you'll know because it says R equals positive 1. Or if it's negative, it'll say negative 1, negative 0.8. And then if it's close to 1, so yeah, I would say anything 5 or above, that's going to be a strong. Anything below 5 is going to be a weak. So 0.6, 0.7, 0.8, strong. 0.9 is real strong. 0.3, 0.2, those are weak ones. Okay. All right. So notes may take a long time today, but it's not hard work. It's just having to type it into your calculator just takes forever. Okay. So that's why I said having it in your hands and treating it like your phone for your texting is a little bit easier than having it on the screen as your Chromebook does. Okay. So it's a little bit easier to have it in your hands. And it's a little bit easier on these than it is on your phone, because a lot of times on your phone, sometimes it's real sensitive to how you how you do things, okay? So here's what we're going to do first. Very first thing. We're not going to make a scatter plot just yet. What I'm going to teach you is how to put it in your calculator. The first thing that you're going to do is turn your stat diagnostics on. And the way you do that is you go to mode, and I'll show you exactly where that is in just a minute. And then down to your stat diagnostics. And then you're going to turn it on. And again, I'll show you where that's at in just a second. Let you get that copied down. This cord is getting on my nerves today. All right, I'll come back to that chart in just a second. I want to show you. When you are looking at your calculator, you see the second key right beside it is mode. Okay, so mode is right there. You're going to go down to stat diagnostics, go on top of on and hit enter. So make sure those stat diagnostics are on. If they are not on, you will not see R. Got it? So that's the only way you're going to be able to see it. When you take your final exam, you have to remember to do this. Okay. You can remind each other the day of. I cannot talk to you the day of. Okay. So I will try to remind you the day before and all of that before your exam, but make sure that this is turned on. Okay. It will not be on your calculator. So to get out of it, I do second mode, which quits and goes back to a regular screen. Okay. So the first thing, make sure that stat diagnostics is on. The second thing you're going to do is you're going to go to stats and you're going to hit enter on edit. All your X's go in L1. I'm sorry.
No, that's
And all your Y's go in L2. So I'm going to go back to your chart. Remember, these are our X's. Oh, sorry. And these are our Y's. So this is what takes so long. Take a second after you've put it in there to check your values. Okay. You don't want to type them all in, do all your work and get it wrong because you didn't go back and make sure that you typed everything in. And I make mistakes when I type. So don't act like, don't feel like I'm being mean when I say that. I have to check mine too, and I make them. So I want to make sure that I get this problem right because this is such easy stuff. Okay. So easy to do. So in your calculator, stat is right under the delete key. So green alpha key, then your X, and then there's stat. So we're going to stat. It's already on edit. So you just hit enter. Make sure that you have L1, L2. If you don't have L1, L2, especially you guys in here, let me know right now. Everybody got it? If you don't, you have to restart your calculator. We'll talk about how to restart, whatever. Do not delete them out. Leave them just like this. In the first box, you're going to type all of your X's. So 0, hit enter. You're going to type in 500, hit enter. 1,000, I'm going to pick my calculator up so I can do it a little faster. 1,500, 2,000. Type them all in. I'm going to show you something. If you guys look, I take 1 second and go back over my L1 to make sure it's okay. 0, 500, 1,000, 1,500, 2,000. Oh, look, I screwed up. So I got to fix that. It's got to be 2,500. So I just type over it. Okay. You just type over it. Very good. Go over to L2 and type all these in. I'm going to pick my calculator up again. 59.0, 59.2. When you get them all in, move up and make sure that you put them in correctly. My first one I put in wrong. I didn't do that one on purpose. I did the last one on purpose. So glad I checked it. 59, 59.2, 61.3, 55, 41.6, 29.8, 29.9, 18.1, 12.4, 0.6. There you go. Give y'all a minute to put it in. Zoomers, there'll be a lot of wait time. I'm watching them to see when they get done putting it in their calculator. I don't want to move on and not have them know what they're doing, okay? So if you're not participating by putting it in your calculator, then you're just going to be there waiting. So just wait. Okay. Your last step, and all I did was write it down. I haven't done it on the calculator yet. Okay. Last step is go back into that stat. You're going to go to calc, over to calc, and then number 4 is reg, linear regression, AX plus B. You got all yours in now? You guys got all yours in? Everybody good? So we got all our values in. There it is. We're going to go back to stat. That's that same key we hit in the first time. You're going to move over to calc and down to 4. When you hit enter, it's going to ask you a bunch of stuff. It's all programmed in just fine. You keep going down until it gives you a new screen. Okay. Right here, stat, and then over to calc. Did you hit stat? You good? And then down to number 4. When you hit enter, it's going to ask you a bunch of questions. You just hit enter till you get this screen. The only thing that we're looking at right now is that very last R. Remember, I told you that's the only way to get it is the stat diagnostics. Okay, those R's will go away if it's not there. So it asks you what type of relationship does the scatter plot show? Our R was negative 0.96. Negative 0.96. There are 2 things that this number tells you. The first one is it positive or negative. So you tell me, is this one positive or negative? How do you know it's negative? It has a negative. It's that simple. The second thing it tells you, is it strong or is it weak? Ooh, why is it strong? Yeah, it's over 0.5. Remember that. I told you if it's closer to 1, this is 0.96 is real close to 1, right? If we round it up, it'll round to 1. So this one is actually strong. Now, what I'm going to do, it says to make a scatter plot. You guys don't have to do that. I'm going to show you what that looks like, okay? So I want you to see it. You do not have to do this. This is what your scatter plot looks like. Can you tell that it's negative? How can you tell it's negative? It's going down, right? Yeah. Are they really close together? Yeah, that's how you know it's strong. So you can look at the graph too, but we don't have to make the graph because we have the R on our calculator. All right. Exercise 2 says using the data to find the line of best fit. So the line of best fit is the line that goes through the most points or gets as close as possible to all the points. Sometimes it may not go through any of the points at all, but it'll be really close to all of them. And sorry, I took up some space. We're going to do interpolation too. Interpolation is estimating within the data. And that's the given data. And I'll explain that when we get there. That just means we would pick anything that falls within this 0 to 5,000, okay? Anything over that would be extrapolation, but we're not worried about that right now. I'll explain what that is. All right. Any questions on this first page? We're still copying down. We'll get done in just a minute and then we'll flip it over. You ready? Good? Almost. So yes. Ms. Foster, don't let me forget that the bells are not ringing.
Okay.
I forgot first period. It's been a day, y'all. Sorry. ACT. So they'll ring tomorrow. They've been given on Tuesday, Wednesday, and Thursday. So we didn't ring bells on Tuesday either. Still got some people copying, so we'll get done in just a minute and move on. And again, when we get done, you're just gonna flip the page. Sorry, A-Dayers, I forgot to give you your notes the other day, but you'll get them on Monday. I super, super, super apologize.
We get on here Monday morning.
Yes.
It was
Thank you.
nice.
She's the woman. Do what? Mine doesn't talk. You good? Okay, perfect. All right, extrapolation is estimating outside the data. So if we decided to estimate bigger than 5,000 on the other one, that would be extrapolation. All right, so then it says on number 1, enter the data into the calculator. We already did that. What is the line of best fit? What you have on your calculator is the line of best fit. So I'm going to show you again what you should have. If you cleared it out or your calculator turned off and it cleared out, remember stat, calc, linear regression, okay? So that's all I did, stat, over to calc, down to linear regression. Hit enter until it gets there. You have the equation at the top. We've already worked with this equation, except for ours is mx plus b, which is fine. It's all the same. If you would rather write the m, that's fine. They give us what a and b is. If you look, a is negative 0.0122. We put an x behind that. And you don't have to do all of the numbers if you don't want to, okay? 2 or 3 will be fine. You don't have to write. See how this one is super, super long? I don't expect you to write 66.28181818. 2 or 3 decimal places is perfectly fine. And don't worry about your rounding either. So if b, that b number is 66.28. Is everybody good? Sorry. All right. The next part says we want to predict the temperature at 6,000 meters. So if we go back, you guys don't have to turn back. I'm just going to show you. That X was meters, Y was temperature. X was meters, Y was temperature. So X was meters, Y was temperature. Okay. We want to predict the temperature at 6,000 meters. So where would that go? Would that go in Y or would that go in X? Which one? What are we trying to predict? 6,000 what? Meters. So meters is X. So what we're going to do is rewrite our equation. But instead of X, we're going to use 6,000. And then we're just going to put all of this into a regular screen on our calculator. So right below your linear regression line, negative 0.0122 times 6,000 plus 66.28, which gives us negative 6.92. What does that represent? What did Y represent? The temperature. Think about that. It's pretty cold, right? Is it possible to get a negative 6 degrees? Yeah, and the higher you get, remember, the colder it gets. Think about the mountains. The higher you get, the colder it gets, right? So that's not terrible. But here's what the difference is between interpolation and extrapolation. 6,000 was our meters. If we go back to our chart stopped at 5,000. Because 6,000 is outside, you don't have to put this down, I'm just writing it. Because 6,000 is outside of the data, that is extrapolation. Okay, it's extra to the data. If we did 2,200, that would be inside of the data. That's interpolation. Got it? So inside is intra, outside is extra. Got it? That's the only difference. I just wanted to clear that up for you. It doesn't matter what it is, okay? Extrapolation can cause crazy answers. Interpolation does not. All right, so we're going to do the same thing. I don't care about the scatter plot. We're not going to do the scatter plot, but we are going to put this in our calculator. So let me tell you how to do that real fast. Okay, you're going to go back to Stat and Edit. Listen carefully. You can just type over these if you want to, or you can go up to L1 and hit Clear and enter. Do not hit delete. Delete will take out the L1 and you'll be in trouble. Kevin, you got this? Go up to L2, hit clear and hit enter, and it will take all of them out. Then put your new values in. The top of the chart goes in L1. So 10, 11, 9, 10, 13, 5, 8, 4. 10, 11, 9, 10, 13, 5, 8, 4. And I'm just going to check it. L2 is 2.5, 2.8, 2.3, 2.6, 3.3, 1.3, 2.2, and 1.1. Remember, your chart should match up at the bottom. Otherwise, what I'm saying is your 4 and your 1.1 should be next to each other. If they're not, you did something wrong. From here, remember, we do stat, calc, linear regression. So stat, over to calc, and number 4, it's going to ask you a bunch of questions. You just keep hitting enter. None of that matters to you. And we get these numbers. We don't have to make a scatter plot. We're just going to look at this. So remember the relationship. Is it positive, negative? Is it strong or weak? So remember, this is the R. Think about relationship means R. Is this a positive or negative? Positive, because it's a positive R value. Is it strong or weak? Why is it strong? It's really close to 1. That's the only 2 things that they'll tell you. You need a pencil? Okay, I just want to make sure. You sure? You sure? Okay. All right, so then it says, what is the line of best fit? Remember, that's when we write our equation. Y equals, what is our A? What is our A? Yeah, and 3 decimals is perfectly fine. Don't forget to put the X behind it. And then our B is a positive 0.123. All right. We're gonna look back at the top for a second. I'm gonna try to get all this on here so you can see it all at one time. That cord is gonna drive me crazy. X was dollars spent, Y was gallons brought. So X was dollars spent, Y was gallons. The reason we need to know that is when we predict, okay? So look at your next equation or your next question. How many gallons would you anticipate buying with $9.50? Would $9.50 go in the X or would it go in the Y? The X. Why the X?
Because X is dollars.
X is money. You guys see it?
Oh,
That's okay. So we're going to do Y equals 0.244. Instead of X, we spent $9.50 plus 0.123. So you're just plugging it in. Just make sure you plug it in the correct spot. Okay. Go back to your calculator and just type that in. 0.244 times 950 plus 0.123. And we had 2.441 gallons. Units are not super important. All of your answers will be in the same units. Flip it over. So this is all you're going to be doing today. Putting it in your calculator, finding that line of best fit, telling the strength, got it? Strength and relationship, or just telling the relationship, the R value. You're going to tell the line, and then you might have to plug something in. So just those three little things, all right? Look at your next chart. I don't know why these notes are so crazy. It's okay. We're going to put our next chart in. Again, you don't have to make the scatter plot. We're not worried about that. We're going to go back to stat and edit. Remember what I said? You can literally just type over these if you want to. That's typically what I do. So that way I don't have to worry about deleting my L1. And check them 1, 2, 3, 4, 6, 8, 10, 12. And then I'm going to pick it up for the other ones because they're bigger numbers. 2.5, 7.6, 12.5, 17.1, 24.3, 37.9, 49.2, 54.9. So 2.5, 7.6, 12.5, 17.1, 24.3, 37.9. There you go. All right. So once you get them in your calculator, stat, calc, linear regression. Is everybody good? So far, so good? Got it all in there? All right. Stat, calc, linear regression. Everybody good? What is our relationship? What's our relationship? It's positive because it's a positive R. Why is it strong? Yeah, 0.9 is real close to 1. Very good. Positive and strong. Line of best fit. Remember, we just do Y equals. What's our A value? 4.92 is perfectly fine. We're going to put our X there. And then we write our B. This time it's a negative, so I'm just going to put a minus 2.54, and I'm going to go ahead and go 8, 2.548. Again, it doesn't matter, 2 decimal places, 3 decimal places. All right. So look back up at the chart and tell me what X represented. Look back up at the chart, what was X? The age. What did Y represent? How fat it was, the weight. We're talking about baby pandas. So the first question says, the first question is the easy one. It's what we've been doing the whole time. What is the approximate weight of a 7-month-old panda? Where does the 7 go if it says a 7-month-old panda? X. So we're going to do Y equals 4.92. Our X is 7 months old minus 2.548. Just like before, we literally type that into our calculator. So 4.92, how about I type it in right? Times 7 minus 2.548. And what do we get? 31.89 pounds. You don't have to worry about units. All right, so this one's going to be a little different because this one says what's the approximate age if it weighs 22. So where is that 22 going to go in my equation? In the weight, in the Y. So we're going to start this equation all the way over, okay? So we're going to do 22 where Y is. And then we're going to keep the X. Sorry. I'm 35 minutes late. I'm not giving you attendance for that. Everybody good? All right. How do I solve this? What are we trying to solve for? What letter? What's on the same side but not with it? 4.92 is with X. So what do we need to get rid of? Yes. So add the 2.548. To both sides. And don't freak out because you got your calculator. Don't worry about it being decimals. So 22 plus 2.548 gives us 24.548 equals 4.92x. How do I get rid of that 4.92 now? Remember, you do the opposite operation. What am I doing between 4.92 and x? Add, subtract, multiply, divide? I'm going to divide to get rid of it. So I'm multiplying these two. I'm going to divide to get rid of it. So we divide by 4.92, and we get that x equals 4.98. So 4 months old, or almost 5 months. Everybody good? This is the one everybody tends to miss because they don't want to use the equation to solve it. Okay, actually do the solving. It's easy. So we got 2 more. Yep, 2 more and that's it. All right, so what happens if you get a chart like this? Because I can't put this in L1. So what you do is you just start it like this. Your first one is going to be 0. Your next one is going to be 1. Your next one will be 2. Because they go in order, they don't skip. 3, 4, 5, and 6. All right, put those values in your chart. So go into stat, edit. I'm just going to type over them. You can get rid of what's left. You can delete inside. Don't delete L1. These are big numbers, 3508, 3766, 4098, 4645, 5126, 5492, and 5836. 3508, 3766, 4898, 4645, 5126, 5836. All right. So I put it in there and it says, what is the R or the correlation coefficient? And then predict the cost of attending college in the 2015-16 school year. So how do we get the R? Stat, calc, linear regression. What is our R value? 0.9959. That's all you do. When it asks for the correlation coefficient, that's R. Then it says predict the cost of attending college in the 2015-16 school year. So you need your equation. Y equals, my A is 409.4 and then an X. And then my B is 3410.428. Here's your chart. What does Y represent? Which one is your Y, your academic year or your cost? Your cost. What is your X? The year, right? Okay. It said predict in the 15-16 year. Look at what we did. 2000 to 2001 was 0. If you look, it's the end of the number. 2001 to 2002 was 1. 2002 was 2. 2003 was 3. 2004 was 4. So what would be 2015? Okay, let me go back over it. 2001 was 1. 2002 was 2. 2003 was 3. What will 2015 be? 15. And we're going to plug it in for the year. Does everybody see that? So 409.4, we're going to plug in for the X plus 3410.428. This is one of the easy ones where you just stick this in your calculator. No hard work. 409.4 times 15 plus 3410.428. It's going to cost us $9,551.43. Any questions? All right, one more. We're going to put this one in. If you don't want to and you just want to watch, that's fine. Here's what we got to look at, though. It says the table shows the amount of money the United States spent on the space and other technologies in specific years. Write the slope-intercept form of the equation for the line of best fit where X represents. Here's your big key. They love to do this on the final exam. Years since 1980. So you have to change these. If it's 1985, how many years has it been since 1980? 5. So we got to change that to 5. If it's 1990, how many years has that been since 1980? 10. 95. 96 is 16. 97 is 17. 98 is 18. 99 is 19. But what about this last one that I didn't do? What about 1980? How many years is it from 1980 to 1980? It's kind of a trick question, but not really. How many years have passed? None. So it is 0. Those are the ones that I'm going to put in my chart. So 0, 5, 10, 15, 16, 17, 18, 19. Underneath, I don't change those. 4.5, 6.6, 11.6, yell at me if I do something wrong. 12.6, 12.7, 13.1, 12.9, and 12.4. Is everybody okay? All right, from here, stat calc, linear regression. We're going to calculate. This is the screen that we need. I'm going to hold it to the side. Predict the amount that was spent on space and other technologies in 2005. So I'm going to write my equation first. When I see the word predict, I know I'm using my equation. Our A was 0.459. We put our X right after that, and it tells you to do that. Y equals A, and then put your X, and then add your B, plus 5.053. What did X represent? What did X represent? Look up here. What did X represent? Year since, right, that's good. That's real good. Year since 1980, right? Everybody remember that? What was Y? What does it say in your chart Y is? Guys, if this is X, what is Y? The money spent. It says predict the amount spent in 2005, but we can't use 2005. We have to know the year since 1980. So how can I figure out how long it's been? How long has it been from 1980 to 2005? Say it again. Yeah. And if you're not sure how to do that, do 2005 minus 1980, and that'll give you your 25. Okay. You can count it or you can do it in your calculator. So we're plugging in 25 years later plus 5.053. Remember when we plug in X, that's the easy one. We just throw this straight into your calculator. So 0.459 times 25 plus 5.053. And we get $16.52 billion. It's crazy, isn't it? It's a lot of money. Any questions? Is everybody good? All right. I'm gonna flip this back in just a second if you guys don't have it. I just want to make sure. All right, we good? All right, we're gonna do this last one real fast because it actually makes you do the Y, solve for the Y. So in 2005, I don't care about these, we're just doing this. In 2005, it's actually, I think it should say known now. Sorry, y'all. That the US spent $14.3 billion. Remember, what we spent was our Y. How does that compare to your prediction? All right, so we did Y equals 0.459x plus 5.053. Remember, X was the year since 1980, and Y was what we spent. So if it tells us that we spent 14.3, which letter am I plugging that in for? It says we spent 14.3. We're plugging that in for Y. So we're going to keep our X. Y'all, it's the same steps every single time. Same steps when you're solving this. So this is the most missed problem on the test is when we have to plug in for Y. Just because it's not that y'all don't know how to solve it, because we've been solving it since the beginning of the year. It's because you just won't do it. Okay. So we're solving for X. We need to get rid of this first. How do I get rid of a plus 5.053? Subtract it. And again, they're just decimals. You can use your calculator, so don't freak out because it's a decimal. So these will cancel out. We get 14.3 minus 5.053. So we get 9.247 equals 0.459x. How do I get rid of this 0.459? Same exact way we did the last one, 0.459. It will be the same way on your homework and on your test. Same solving skills. That'll cancel out and it gives x equals 9.247 divided by 0.459, 20.15. Now the difference is, and you're about to get into this on Monday, I think it's Monday. I think you're just practicing this stuff tomorrow. But when you're comparing, is it Monday that you're teaching? Okay. All right. So comparing is Monday. All you're doing is looking at this and how it compares to the $14.3 billion. So I'm gonna flip it back. I don't like these are on the same page or on different pages. Notice how this is going up. Everybody see that? We have 20.15. So year 2000 would be 20, right? Is everybody good with that? And we had 14.3, I think was the answer. Yeah, 14.3. Does that look pretty good? What do y'all think? That's all I was asking. Compare it. That's it. Is everybody good? All right. You'll do more with comparing later. Zoomers, that's all we're going to do. So I'm going to stop sharing and stop recording. You guys that have your notes in here, you have the quiz. Everybody else, the quiz is on Canvas this time. No Edia this time. It's on Canvas. Guys, can y'all please stop talking? Guys, shh, 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 shh. And then I'll let you guys go. If you give me just a second to mark you. All right. Do you want anybody to stay? Okay, Hunter, please stay for just a minute, but I got your attendance. Georgiana, I got you. Corbin and Lucas, I got you. Corbin, if you'll wait, I'll answer your question. Matthew and Natalie. Corbin, you'll have to tell me what you were doing yesterday.
It wasn't yesterday. It was Tuesday. Remember when I had the one question left?
Yeah, that's what I meant. But what were you doing?
Oh, let me go to it right quick.
Because I can look at the exact question you're on and help you out a little bit better than.
All right, hold on. It's loading.
Oh. Was it actually Tuesday's assignment?
Yeah. Wait. No. Well, it was a distance and midpoint.
Perfect. Okay. That was not the right one. Distance and midpoint green group. All right, Corbin. I can see what you're doing. So I'm gonna write this down and then I'm gonna share my screen with you so you can see it, okay?
All right.
-16, 1 is -5, and 5. Okay. This will be real quick. Okay, so this is what you have, and you're finding the other coordinate over here, whatever it is.
Yeah.
So how far is it on a number line from -6 to -5?
1.
And did I move up or down going from -6 to -5?
Up.
So it'll be a +1. So it's a +1 right there. Okay. Then how far is it from 2 to 1/2?
2 to 1/2.
Remember, you can subtract them. Okay.
Would it be
Minus 0.5 is.
2.5?
You see my screen?
Yeah. Does it say 1.5?
It does say 1.5. Then the question is, when you go from 2 to 0.5, is that an up or a down?
Down.
Down. So we minus 1.5. So then we put these in our calculator. What is -5 plus 1.
-5 minus 1 would be -4.
-4. That's your first coordinate. And then 0.5 minus 1.5.
Would that be 2?
Look at it. Can you see my screen?
Would it be 0.5?
Can you see my screen?
Well, I kind of like had to like zoom it down so I could look at my problem at the same time.
We'll pop it back open.
Yep, -1.
-1. There you go. So there's your coordinate.
So that's what the answer would be.
Yep. So try that and see if it works.
I got to put the parentheses right.
Pretty sure.
So it was -4, -1.
Yes.
And then the parentheses. No. Yeah, I got it. That was the last one, so I finished it.
All right. Good.
So what are we working on today?
It's a Canvas assignment. So if you go in Canvas underneath the module for today, look for 225. It's just a quick quiz.
All right, hold on. I got to get to it. The correlation and causation.
And line of best fit. Math 1 quiz.
Homework upload. Upload your picture of your homework here. So I'm about to go to that.
See it?
I clicked the wrong one. I didn't click the PDF.
Should
Yeah, I got it.
Okay, good. Perfect. All right. So you are good to go. And you can go work on that.
All right.
If you need anything else.